Mr. Williams. Example 1. Determining whether two quantities are proportional. Tell whether x and y are proportional and explain your reasoning. So let's go ahead and start off by making a quick table of y ordered pairs. So we know it's an XY format. So the first one would be 1, negative 2, then 2, 0, then 3, 2, then 4, 4. And as always when we graph, we start at the origin. So I'm going to move to the right on the x-axis 1 space, and then down 2 for my first location. On the second one, we have starting at the origin and moving right 2 and staying there because the y value is 0. Now for the third one, so we have 3, 2, so I'm going to start at the origin, move to the right 3, and then up 2. And for the last one, 4, 4, starting at the origin, moving right 4, and then up 4. And now I'm going to go ahead and connect those. You can see it does make a line. However, it does not go through the origin. If it went through the origin and created a line, then it would be proportional. So this one is not proportional. All right, on to the second one. Let's go ahead and make our table. We start off with 0, 0, then 2, 2, 4, 4, and 6, 6. All right, plotting the first one. We see that we're going to start at the origin. We're not moving right and we're not moving up. So the dot is the origin. On the second one, we have 2, 2. So we start at the origin, move to the right 2, and then up 2. The third one, we have 4, 4. So we moved right to the 4 and up 4. And lastly, we have 6, 6. So we start at the origin, move right 6, and up 6. Let's go ahead and connect those. And we see that it does form a line, and it does go through the origin. Those are the two key factors for something to be proportional. So this is proportional. Math with Mr. Williams. Example 2. Graphing a proportional relationship. The cost y in dollars for x ounces of frozen yogurt is represented by y equals 5/10 times x. Graph the equation and interpret the slope. Okay, so let's go ahead and do that. So first we need to complete our table. So let's go ahead and start off with 0, 1, 2, and 3. Let's go ahead and place the first value in. So we have y equals 5/10 times 0, which should result in 0. So my order pair would be 0, 0. For the next one, we have y equals 5/10 times 1. Well, 1 times anything is the number, so we have 5/10 for our answer, leaving me the order pair of 1, 5/10. Now for the next number, we have y equals 5/10 times 2. That will result in 1, leaving me my order pair of 2, 1. And for 3, so we have y equals 5/10 times 3, leaving me 1.5. So my order pair would be 3, 1.5. All right, let's go ahead and graph it. So we see 0, 0 is the first one. The next one is 1 and 5/10. So we go over to 1 and up to 5/10. Then we have 2, 1. So we go over to 2, up 1. Then we have 3 and 1.5. So we go to 3, up to 1.5. Let's go ahead and connect those. We can see this is a proportional relationship because it is a line and it goes through the origin. So then we have to find the slope. Well, the slope is the easy part. Y equals mx. It is the m in that series. So therefore, our slope is 5/10. Math with Mr. Williams. Example 3. Writing and using an equation. The weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. First part says write an equation that represents the situation. So let's just start off with the easy one. How about y equals x? Let's go ahead and put our numbers in to see what they're talking about. So we had 105 pounds on Earth, and that's represented by the x. And then we had 15 pounds on Titan, represented by the y. So we have 15 equals 105. Well, we know that's not true, so we ask ourselves, well, how do I get there? So the question is, how many times 15 to get me 105? So in that case, we would take 105, divide by 15, and we would see that would get us 7. So that means that 7 times 15 would get us our 105, So if we just take out the numbers and put the letters back in, we have 7 times y equals the x for our equation. All right, so what that means is 7 times y equals x. Well, that's going to solve for the weight on Earth. Now, to cancel that, to reverse that, to find the weight on Titan, what we need to do is solve the equation and move the 7 to the other side. To do that, we're going to divide by 7 on both sides, canceling the left, giving us our new equation of y equals x over 7. So here are two equations that work, and that y equals x over 7, that is going to be for the weight of someone on Titan. So if we're looking for that weight on Titan, we'll use the y equals x over 7, and if we're looking for the weight on Earth, we would use the 7y equals x. All right, so let's go to the second part. It says, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? So this time we're looking for the weight on Earth, so we go back to the 7y equals x. Let's go ahead and substitute our 3.5 in. And 7 times 3.5 would get me 24.5. So we know the person on Earth would weigh 24.5 pounds.